Hello, in earlier chapters we have learned about Bayes' theorem, where we could switch the place of condition and the event. So in other words, we were able to calculate probability of, let's say, A given B using probability of B given A. So we establish a formula that you multiply this one by something and then divide by something else, and this gives you that. So this is called Bayes' theorem, and it is the basis of estimation, detection, inference, machine learning, and so on. And now we have learned about joint PDFs and also the conditional probability density functions. So we want to upgrade this Bayes' theorem using the joint probability density functions. So we have seen that the joint PDF of two random variables is always equal to the marginal PDF times conditional PDF, and is equal to joint PDF of two random variables. So using this equation, we want to rewrite the Bayes or upgrade the Bayes theorem and total probability theorem. Obviously, we know that the marginal PDF is obtained from the joint PDF. So the marginal PDF is always equal to integral from minus infinity to plus infinity of the joint PDF. So if you have the joint PDF, you get the marginal PDF, and then you can divide it by this one, you can get f y of x. So in other words, the conditional PDF of y given x is equal to the joint PDF fxy of x and y. And then you can write integral over y from minus infinity to plus infinity of fxy of x and y dy. Okay. So we can write this one, and this formula is similar to what we had for the obvious case of discrete type random variables. So this is a formula that you can generalize it for more than two random variables and so on. So for the discrete type case, we had this one. So the probability the conditional probability mass function. So this is probability that y or the mass of the probability at yk, given that x is equal to another value, and this was obviously equal to what we want. So for discrete type random variables, you could define a Markov matrix denoted by that, and which is this conditional probability. So, or you could say that this is transitional probability. Then let's say if x is the input, and it can take x1, x2, etc., and let's say xi, etc., and then y is another random variable which can take y1, y2, and then yk, etc. So, and then you have a matrix that determines these probabilities. Okay, so this is called either transition matrix or Markov matrix. So this is just a notation for your knowledge to know.